Alright, so first things first, you're going to take your papers and you want about a 1/2 inch overlap, and you're going to fold over so that you have more 1/2 inch overlaps. Notice if you have two colors of paper, these two are the same color, but it is two flaps. Okay? When you turn it over, this top one we can just write our title, Properties of Exponents, and from here we'll be able to identify that right now we're going to be talking about the multiplication properties. And we're going to be talking about the multiplication properties first. Alright, so the first property that we're going to work with is our product of powers property. Next, we will do the power of a power. And after that, we will have power of a product. And that should do it for the properties that deal with multiplication. Alright, so let's see. The product of powers property. So we're going to open up this flap and we'll be able to write in here everything that we need. And it'll be covered up. So we can try and memorize what's in there and take a look at it, and we'll be able to use this effectively. Now in words, the product of two powers, and remember product just means multiplying two numbers. The product of two powers with the same base equals the base raised to the sum of the powers. Alright, we're going to make sense of that in a second. The key words here are base and sum of the powers, and I guess product. So remember, product means you're going to multiply two numbers. The base, we're going to see in a second, is the number that's raised to a power. And when you say the sum of the powers, that just means you're going to add the powers together. All right, so what does this look like with numbers? Okay, so we'll make sense of it with a numbers example. Now, if we have the base 6 raised to the power of 7 multiplied by 6 raised to the power of 4, okay, here we have a power. It says that the product of two powers, the product, okay, with the same base, our base is 6, equals the base raised to the sum of the powers. So we're going to take this base 6, and we're going to find the sum of the powers. So that should be 7, 8, 9, 10, 11. So 6 to the 11th power. Okay, what does that look like with variables? All right. So if you have a to the m plus, times a to the n, this will be equal to the same. We're going to take the product of two powers with the same base. Our base is both a. The base is equal to the base raised to the sum of the powers. So we're going to take that base a. We're going to find the sum of the powers. Okay? All right, and that's really the gist of the product of powers property. We're going to apply this tomorrow. All right, now the power of a power property. So we're going to flip over here, so we're going to be able to write this. So see, it looks like this. And when you flip it up, you can figure out, okay, what does this mean? Okay. All right, power of a power property. So in words, it is a power raised to another power equals that base raised to the product
Ms. Munoz, you need to go to room 412, please. Ms. Munoz, go to room
of
412.
the exponents. Okay? So if we have a power raised to another power, it will equal the same base raised to the product of the exponents. Remember, product just means multiply. Okay? So let's see what that looks like. If we use numbers, we would have a power. Okay, so we have 6 raised to the 7th power raised to the 4th power. And that's how we're going to write that. Okay, we have a power raised to a power. So that's going to be equal to the base, which is 6, raised to the product of the exponents. So product of the exponents, that's going to be 7 times 4. So that will be 6 to the 28th power. And what does that look like with variables? Okay. So again, if any non-zero number is raised to a power, such as a raised to the power of m, which is then raised to the power of n, so we have a power raised to a power, it's going to be equal to the base a raised to the power of the, or raised to the products of the exponents. So we have the products of m and n, which would be m times n, which would just be mn. Okay? And we'll get some more examples to work with tomorrow. All right, now we're moving on to the power of a product. So what is this in words? The power of a product. Now the power of a product is a product raised to a power equals the product of each factor raised to that power. Okay? Now, let's see what that looks like in numbers. A product raised to a power equals the product of each factor raised to that power. Oh man, lots of vocabulary here. All right, so in numbers. Okay, so let's say we have a product, which just means two numbers multiplied by each other, raised to a power. So let's say we have 2 times 4 raised to the 3rd power. Okay, it's going to be equal to the product of each factor, these are our factors, 2 and 4, raised to that power. So we're going to have the factor of 2 raised to the 3rd times the factor 4 raised to the 3rd. So I have a product, 2 times 4, raised to a power to the 3rd, equals the product of each factor, 2 and 4, raised to that same power. So they're both raised to the power of 3. Okay? It's kind of like distributive property with the exponents. Okay? Alright, so let's see what that looks like with variables. Alright, so if we have a product, A times B, raised to a power, let's call it n, it is equal to the product of each factor, okay, so the product of each factor, that's going to be A times B, the product of each factor, raised to that power. So they're both going to have to be raised to the power of n. Okay? And we'll take a look at that a little bit more tomorrow. Now let's turn back. I'll give you one example to attempt. Okay? The product of powers property. Example. Two to the fifth times 2 to the sixth. So tell me what that's going to equal. Now, the power of a power property. Let's say you have your numeric problem. Let's say we have 7 raised to the 4th, which is raised to the 3rd. And let's try x squared raised to the negative 4. Okay, and you're going to have to remember what we did in class today. And finally, the power of a product property. Let's try if we add 3x, the product of 3x raised to the power of 2. Okay, so give those a try, and I will see you in class tomorrow. Good luck.